In this video, we're going to look at how to solve linear equations. We're going to start with some basic one-step or two-step equations and work our way up to some that are a little more difficult. So remember that when you're solving an equation, you're trying to isolate the variable by using inverse operations. So for this first equation that says x plus 8 equals 13, we need to get rid of the plus 8 by using the inverse operation of addition, which is subtraction. So we're going to subtract 8 from both sides of the equation. Remember, when you're working with equations, anything you do to one side you have to do to the other. So this gives us x equals 5 as our solution. Okay, for the second equation you have 4x equals 22. We want to isolate our x, so we need to get rid of the 4 in front of it. And anytime you have a number sitting right in front of a variable with nothing in between, that means they're being multiplied. So the inverse operation for multiplication is division. So we're going to divide both sides of the equation by 4. So those cancel, and we get x equals, and then 22 divided by 4 is not a nice whole number, so we want to reduce this fraction instead. So to do that, you try to think of the largest number that'll divide into both of these numbers evenly, which in this case is 2. 2 goes into 22 11 times, and 2 goes into 4 2 times. So our answer is 11 halves. And remember, for any equation, if you're unsure if you solved it correctly, you can take your solution and plug it back into the original equation and make sure that you have a true equation. So for example, on this first one, if I take this 5 and plug it back in where x is, I get 5 plus 8 equals 13, and 5 plus 8 is 13. So when you end up with a true statement like that, then you know that you've solved it correctly. Okay, for our two-step equations, we have 3x minus 5 equals 16. So here's the variable that we want to isolate. So we have two things that we need to get rid of. We have a 3 in front of the x, and we have a minus 5 after the x. When you're solving an equation, you always want to undo your addition and subtraction first, and then your multiplication and division after that. So we actually want to get rid of the minus 5 first, and the opposite of subtracting 5 would be to add 5. So we'll add 5 to both sides of the problem. So we'll get 3x equals 21. Okay, and then we're still not isolated. Now we still have to get rid of that 3. Remember, this is multiplication, so I need to divide both sides by 3. So I'm going to get x equals 7 as my solution. Okay, the next equation says x over 7, or x divided by 7, plus 1 equals 9. Alright, so here's what we want to isolate. So we need to get rid of the 7 and the 1, but because this is division, we're going to do that last. We're going to get rid of the plus 1 first. So we're going to subtract 1 from both sides. So we have x over 7 equals 8. And then to get rid of the division by 7, the inverse operation for that is multiplication. So we'll multiply both sides by 7 so that these two cancel out, and we just get x. And then 8 times 7 is 56. So 56 is our solution for that problem. And again, you can check any of these problems that you want to just by plugging your solution into the original problem. Always make sure you go back to the very first equation when you plug in. Okay, so these next two examples are some problems where you have more than one variable on the same side of the equation. Okay, when that happens, you want to combine like terms. So like in this first equation, we have negative 20 equals negative 4x minus 6x. Well, negative 4x and minus 6x or negative 6x are like terms. Like terms have the same variable with the same exponent on the variable. Okay, so to combine those, negative 4 and negative 6 makes negative 10. So we'll have negative 20 equals negative 10x. Once you get your like terms combined, then you want to work on isolating your variable, and your variable is the x right here. So we've got to get rid of that negative 10 in front of it. Now, I always have some people who want to try to add 10, but remember, this is not a subtraction of 10, this is multiplication of negative 10 because it's right next to the x. So we fix that by dividing by negative 10 on both sides so that these cancel. Negative 20 divided by negative 10 is positive 2 equals x. Okay, the next problem says p minus 1 minus 8p equals negative 8. So here are our like terms. We have a p or a 1p. You can imagine an understood 1 being in front. And a negative 8p. So we need to combine those. A positive 1 and a negative 8 make negative 7. So this will be a negative 7p. Then we also have this minus 1 in here equals negative 8. Okay, so now we want to work on isolating this p. So we got to get rid of the negative 7 in front. We also have to get rid of the minus 1, but remember you always want to get rid of the addition and subtraction first. So we're going to add 1 to both sides to get rid of that. So we have negative 7p equals negative 7. Okay, and now to get the p by itself, we'll need to divide by this negative 7 that's sitting in front of it. So those cancel. And negative 7 divided by negative 7 is 1. Anytime you divide something by itself, you get a 1. So p equals 1 is our solution. Okay, the next two problems have more than one variable, but those variables are on opposite sides of the equation. So we're going to approach these a little bit differently. So the first equation says 8x minus 2 equals negative 9 plus 7x. So this 8x here and the 7x here are our like terms, but because they're on different sides of the equation, we can't just combine them. What we have to do is we have to use an inverse operation to get rid of one of them. Okay, so I want to get rid of this 7x, and it's positive. It's an addition of 7x, so to get rid of that, I'm going to subtract 7x. Whatever I do to this side of the problem, I also have to do to this side of the problem. So I'm going to do it on both sides. 8x minus 7x is 1x, or just x. And then bring down the minus 2 equals negative 9. Okay, so now that we've gotten those together, we want to isolate our x by getting rid of this minus 2, so we'll need to add 2 to both sides of the equation. So we have x equals negative 7. Okay, over here we have 3w minus 7 equals 2 minus 9w. Alright, this 3w and this minus 9w or negative 9w, we need to get those on the same side. So I'm going to take this minus 9w and I'm going to add it to both sides so that I don't have it over here anymore. 3 plus 9 is 12, so I have 12w minus 7 equals 2. Okay, now to isolate this w, remember addition and subtraction first, so I have a minus 7 here that I want to get rid of, so I'm going to do the opposite. I'm going to add 7 to both sides. So I have 12w equals 9. Alright, I have multiplication here, so I'm going to get rid of that 12 by dividing on both sides. Alright, 9 divided by 12 is not a whole number, so let's reduce that. The largest number that'll go into 9 and 12 both is 3. So 9 divided by 3 is 3, and 12 divided by 3 is 4. So our answer is 3/4. So I want you to understand the difference in how you solve an equation where your variables are on different sides and when you solve an equation where your variables are on the same side. Just remember, if the variables are on the same side, you combine like terms. If they're on different sides, you need to get rid of one of them so that all of your variables are on one side or the other. Okay. Next, we want to look at some equations that have parentheses in them. When you see parentheses, the first thing that you want to do is get rid of those parentheses by distributing by whatever's sitting in front. So in this first equation, I have 12 equals negative 4 times the quantity, negative 6x minus 3. I want to take this negative 4 and distribute it to both terms in my parentheses. Okay, so I'm going to bring down the 12. Negative 4 times negative 6x would be positive 24x. And then negative 4 times negative 3 is positive 12, or plus 12. And then we work on isolating our variable. So the first thing that we'll need to do is get rid of this plus 12 by subtracting 12 on both sides. And this one's a little different because it actually cancels in places. This cancels, which gives me 0. And then I have 24x, and then this cancels. Alright, now we want to get rid of the 24 that's in front of the x by dividing by it. So divide both sides by 24. And remember, 0 divided by anything is still going to be 0, no matter what that number is underneath. So our solution is actually 0 for that one. Okay, the next problem says 5n plus 30 equals negative 2 times the quantity 1 minus 7n. I want to go ahead and distribute that negative 2 times what's in parentheses. I'm going to go ahead and bring down this 5n plus 34. And then when we distribute this, negative 2 times 1 is still negative 2. Negative 2 times negative 7n is positive 14n, so plus 14n. Okay, now this problem looks very similar to these up here. I have a variable on each side of the problem. Remember, we want to get rid of one of those. So choose which one you want to do an inverse operation for, and it doesn't matter. You should get the same answer either way. I'm going to go ahead and take this positive 5n and I'm going to subtract it to get rid of it here, which means I also have to subtract it here. So I'm going to bring down the 34, so I have 34 equals negative 2, and then 14 minus 5 is 9, so plus 9n. Okay, so this one looks a little bit different just because our variable's on the other side, kind of like this one was over here. I still want to get rid of this negative 2 or this minus 2 before I worry about that 9 that's sitting in front of the variable. So since that's a negative 2, I want to add 2 on both sides. So 34 plus 2 is 36, which equals 9n. Now I want to get rid of the 9 by dividing it out. 36 divided by 9 is 4, so 4 equals n, or n equals 4. Alright, and these last two equations just kind of have a combination of everything in them. We've got some parentheses, we've got variables on both sides of the equation, we have variables on the same side of the equation, so we're just kind of taking all the skills that we've looked at so far and putting them together. Alright, so the first one says 2 times the quantity 4x minus 3 minus 8 equals 4. Remember, when we see parentheses, we want to go ahead and get rid of those. So I want to distribute this 2. 2 times 4x is 8x. 2 times negative 3 is negative 6. And then we want to go ahead and bring down the minus 8, and then bring down the rest of the equation. Okay, before we solve this, we need to look at the fact that we have some like terms that need to be combined right here. We have a minus 6 and a minus 8. Negative 14. And then next we have x's on both sides of the equation. We have an 8x and a 2x, so we need to get rid of one of those. And it doesn't matter, just choose one. I'm going to get rid of the 2x. So since it's a plus 2x, I want to subtract 2x from both sides. So I have 8x minus 2x, which is 6x. I want to isolate this x. Okay, I want to get rid of my minus 14 by adding 14 on both sides. And then I want to get rid of the 6 in front of the x by dividing it out. So divide both sides by 6. So you get x equals 3 as your solution. Okay, and the last problem. All right, we have two sets of parentheses, so I actually want to distribute the -3 to this set, and I want to distribute to this set. So -3 times 4x is -12x, and then -3 times 3 is -9, so -9. Okay, plus 4 times 6x, that's going to be 24x, and then 4 times 1, that's a +4, so plus 4 equals 43. Alright, from here we should notice that we have two sets of like terms. The -12x and the 24x are like terms. We combine those, -12 and +24, that gives us +12. So +12x takes care of these two terms. And then we also need to combine the -9 and the +4. -9 plus 4 is -5. So -5 equals 43. Alright, now we want to work on isolating the x, which means we're going to need to get rid of this -5, so add 5 to both sides of the problem. So we have equals 48. And then we want to get rid of the 12 by dividing. And 48 divided by 12 is 4. So our solution is 4. So I hope the process of solving these equations makes sense. Just remember that you can always take your answers and plug them back in, and that's always a good idea if you're unsure if you've done it correctly, to just check your answers and make sure you actually get the number that's on this side of your problem.